Okay, great.
Welcome to HECTV's live interactive program that's part of St. Louis.
The whole production is pulled together.
It's going to be a steel bridge.
The way the cockpit is designed.
The highest rated green building in the world.
Welcome to HECTV Live.
Welcome to HECTV Live. Hi everybody, I'm Tim Gore, your host for the program, and I'm happy to welcome you to the St. Louis Science Center, where today we're going to be investigating climate change. You're seeing now a video of the exhibition as you would walk into it here at the St. Louis Science Center. It's a phenomenal interactive exhibition which gives people an idea about how the climate has been affected by mankind over the course of basically the last couple of centuries. What is the carbon footprint that we've made a difference? How's it affecting not only human existence on the planet, but also animal existence on the planet? And ideally speaking, what could we potentially do about it? All of those are issues and questions that are raised by the climate change exhibition. Hopefully you've had a chance to view our preliminary preparatory materials if you're joining us interactively. We welcome all everybody's participation in today's program. Our interactive schools, I'll be coming to you throughout the program to obviously ask your questions and get your comments. But don't forget, if you're watching over television or over the web, you can email us your questions and comments to live@hectv.org. That's live@hectv.org. Thank you all for coming and welcome to the St. Louis Science Center. We're in the section of the exhibition which deals with our folks' carbon footprint, and I'd like to introduce these fantastic two guests who are here with us. To my right, of course, is Cara Valenta. She's the Associate Museum Director for the St. Louis Science Center. Carol, thanks for being here.
Oh, and welcome everyone out there that's coming to join us today. We're glad you're with us.
And to my left, Dr. Bill Dannevik, who is a professor at St. Louis University, the area of meteorology. Am I remembering right, Bill?
That's correct, yes.
Thanks very much for being here.
Great
Good morning.
Good to be here.
Well, we're going to begin today's program with a little bit of understanding what is the difference between climate and weather. And we know that that is a question that we actually put out to our student groups in advance of the program. So I want to go to Putnam Valley Middle School, because Putnam Valley, I know you guys have thought about this topic. And let me know your name. Please come in and say hello. And what do you think is the difference between climate and weather?
Climate is different from weather because climate has to do with weather all over a specific range and over a long period of time. Weather has to do with a specific day. It's not general. It has to do specifically with what is going on in a specific place at a specific time.
Thank you, Putnam Valley. What they're telling us, Dr. Dannevik, is that weather deals with specific events on a day and a time and a place, and climate is what we would see over time, a general idea about what the temperatures would be and the general nature of weather over a period of time. Yes. Is that the basic difference?
That is certainly a very good characterization of the difference. An example would be, what's the average high temperature going to be in January for the next 30 occurrences of January? That's a climate question. What's the temperature going to be tomorrow at a particular location is more of a weather prediction question.
So the fact that we're supposed to be 63 today is a weather question. The fact that it snowed on Monday morning in St. Louis is a weather question. Yes. And we shouldn't necessarily think that the climate's being bizarrely different because I get snow on Monday and 72 tomorrow.
Right.
And Carol, that question about climate versus weather is kind of central to what you're interested in this exhibition as people think about climate change over time?
We thought that was a very important part of this because people are responding to those day-to-day things and saying, well, what does this have to do with climate change if it snowed today? But if we watch that gradual change in the Earth's temperature over time, that's where we begin to see that the climate of the Earth as an average has changed.
And that's an important thing to consider as we look into some of our topics today. We're going to begin by talking about carbon footprint, and that's why we're here. And at this moment, I'm actually going to turn my back to this camera, and our other cameras are going to move around because I want you guys to have a chance, one camera, to show these different screens we've got going here. We're going to start, and Bill, I'll just invite you to move to my left now too, and you and Carol can just join me right over there. We're going to start by talking about people's use of different kinds of light bulbs, incandescent versus CFL light bulbs. And this is some information I ask our student groups to consider in advance of the program. And Bill, perhaps just a little bit of information would be good for background. When we talk carbon footprint, what do we mean and why does it matter?
Well, the carbon footprint is sort of a concept that quantifies how much carbon has to be emitted into the atmosphere to accommodate a certain activity that we might enjoy or want to do. For example, turning on a light involves some power plant somewhere creating a few watts of energy, and that involved perhaps burning some fossil fuel and therefore releasing some carbon into the atmosphere. So the footprint is sort of the colloquial way of looking at how much carbon are various activities responsible for putting into the atmosphere.
To our interactive groups, I'm going to ask you guys for your ideas on these topics, like how many light bulbs you might have in your house, that kind of thing. You've got that information. But I want to start with one of our view-only schools who sent us information in advance. I'll say hi to Forest Heights Academy of Excellence. That's in Baton Rouge, Louisiana. In Forest Heights, I'm going to, as we go to this particular graphic, we're going to look at incandescent bulbs. And I learned from you guys that 7 of your students said that you had between 21 and 30 light bulbs in your house. And interestingly enough, the U.S. average for light fixtures in America is 30 light bulbs in your house. And that you learn as a result of that you actually end up burning 3,078 pounds of carbon dioxide, enough to fill 6 different balloons. Now, if you were going to reduce those carbon emissions by switching from 30 incandescent bulbs, let's say you only wanted, 10 CFL bulbs in your house, you would save actually 482 pounds of carbon dioxide. So this is a very cool interactive exhibit you've put together, Carol. And the interaction really matters for you. You want kids to see the impact of their actions on the environment.
We thought that was very important because if you have questions, you want to know if I choose this, what happens? If I choose this, what happens? And without a person to interact with and know all that data, the very best is an interactive like this that lets you have that kind of information. And it's really terrific because you can try out, well, I'll go from 10. What happens if I do 15 or 20? It really gives you a good way to see how you can make a difference.
Very cool, very cool. I want to go to Mount Tabor Elementary School in New Albany, Indiana. Mount Tabor, do you have a light bulb number that's different than the 30 we just saw that you'd like to share, and we can see how many pounds of carbon footprint you're creating? What is that, Mount Tabor?
Who had the CFL info? Jessica, go ahead. What did you have?
I had 27 light bulbs, or CFL light bulbs in my house.
She had 27 in her house.
27 in your house. Well, let me go back then and see if it'll give us 27 exactly. Let's see how close we can get. There's 20, 22, 24, 26, 28. Well, let's assume for a minute you've got 26 in your house. We'll be perilously close. You actually, over the course of a year, are creating 2,667 pounds of carbon dioxide. So thank you, Mount Tabor, for that information. Let's switch now from incandescent bulbs, and let's talk a little bit about your CO2 emissions as they come to us from what you and your family drive. Interestingly enough, every gallon of gasoline burns about 19 pounds of carbon dioxide. Every gallon of gasoline burns about 19 pounds of carbon dioxide. And we learned from Sacred Heart Catholic School in Sedalia, Missouri, who's joining us via the internet today, that they have 4 students whose family drive SUVs. So Sacred Heart, if we were to take that information and we were going to go to an SUV, you'll notice that you only get on average about 14 miles per gallon. And if you drive about an average of 33 miles per day, whoops, I'm going to go, the U.S. average of like 33 miles per day, you're going to use 16,185 pounds of CO2. That's a lot of CO2. And I noticed, Carol, we have a big screen here that shows that information as well. So we don't see it just on the small screen here. People are able to see it on the big screen. So you could have student groups who come through and could actually interact the way these kids are.
Or sometimes we have many family groups here, and this is a way for them all to talk together and see what kind of difference they can make.
Let's go to Stonewall Elementary in Fayette, Kentucky. Stonewall, do you guys want to talk about one of the kind of cars your family might drive? Whether it's an SUV or a subcompact car or a hybrid? Give me an example that you guys would be interested in. Stonewall, I'm not hearing you guys right now, so I'll come back to you. Let's go to Arts Academy at Summit. Arts Academy, is there another vehicle you'd like to check out with carbon footprints?
Has something other than SUV. Miles?
Minivans?
Minivans, excellent. Let's go to minivans. See what that happens. It might be interesting to note that our producer, Laura Susik, drives a minivan as well. So we'll just see how we're going here. You get about 18 miles per gallon in a minivan. Interestingly enough, assuming you're going to drive that U.S. average of 33 miles per day again, You guys are burning 11,801 pounds of CO2. That's enough to fill up one hot air balloon. Now, as people think about this, Bill, how much difference does it really make when they think about driving, about like if I choose to drive less miles, if I choose to use public transportation, if I were to switch, for example, from a minivan to a hybrid, these kinds of actions would make a difference?
Oh, it does make a difference, especially when that's accumulated over a lot of population. So you might think that individual decisions, well, gee, it's not going to make all that much difference. But if you can get an entire community or an entire nation to adopt more carbon-friendly attitudes and activities, it can truly make a difference. What I like about this exhibit is it also brings it down to the personal level. I mean, you can very easily turn on your light switch. You can think about, well, that created a certain amount of excess carbon dioxide in the atmosphere. So really down to a personal level.
Before we start to talk about trees, I want to see what questions you students might have for either Bill or Carol about carbon footprint, about this topic that we're discussing. So let's once again go out to Putnam Valley Middle School in Putnam Valley, New York. Putnam Valley, you guys have a question right now for Bill or Carol?
Well, all the kids in our class, we had at least 50 trees, all of us, except one person. And some of us had over like 2,000. Oh, how much would 2,000 trees affect the carbon footprint?
How much would 2,000 trees affect the carbon footprint? I'm not sure our numbers are going to go that high, but let's go to the screen and see.
Let's find out.
So you had, and we'll go to that and see. Trees are important because they actually absorb CO2, and they do it quite successfully, right, Bill?
They do indeed.
Indeed, it says 145 pounds of CO2 per year per tree. So we were going to switch that. Well, we go up to 100 trees, so we'll just do a quick math exercise, because did I hear it was 200 trees in Putnam Valley? 2,000? Well, if we do 100 trees, then you have absorbed 14,500, we see that up on the big screen. 100 trees would absorb 14,500 pounds of CO2 per year. So Putnam Valley, if you take that 100 trees and you multiply it by 2,000 trees, you'll know exactly how much CO2 you guys would absorb per year with those trees. That's really cool information for you guys to know and to figure out. And if you want to share that later in the program, after you do that math, feel free to do so. Let's go back to Mount Tabor Elementary in New Albany, Indiana. Mount Tabor, a question for either Bill or Carol about carbon footprint?
How much would one large truck take?
One large truck. Well, let's go back and find out about that. I go right to here, and we go to an SUV truck, and we've got one truck. And let's say you have to commute quite a distance, okay? I know where Mount Albany, Indiana is. If I'm remembering right, it's on the Ohio River, not too far from Louisville, Kentucky, maybe right across the river from Louisville, Kentucky. And so let's say you have to drive about, 50 miles a day to get wherever you're going for work. Then at 50 miles with your truck, you are actually yearly creating 25,289 pounds of CO2 emissions. That's enough for a little over 2 hot air balloons. When you think about it as hot air balloons, Bill, that's huge amounts, isn't it?
Right.
Well, it's much easier to visualize.
It's much easier to visualize. I can picture a hot air balloon going up and thinking it's going to fill with CO2. Let's go back to Stonewall Elementary in Fayette, Kentucky again. Stonewall, a question for you guys on carbon footprint?
How much would it take for 5 semi-trucks?
Oh, semi-trucks. I'm not sure I can give you the semi-truck information because they don't show me that here. So obviously a semi-truck would, I assume, use much more, but does it matter? That leads me to a fuel question, because semi-trucks almost always run on diesel. Yes. And obviously if I'm driving my car, I'm using unleaded or potentially, well, now it has to be unleaded. But does diesel affect it in a way that, the students might be interested in knowing about?
I don't think it's a dramatically different amount of pollutants and other gases connected with combustion of diesel. It's a lower grade petroleum product, so it might have certain emissions that are actually higher than gasoline, but I don't know, I don't think the carbon dioxide is dramatically different per gallon, let's say.
Okay, and Summit Arts Academy, let's go to you guys for our final question about carbon footprint. Anything you might want to know about this topic?
How much would it take for an SUV to go 10 miles?
An SUV to go 10 miles. We'll just take that information and figure it out for you really fast. Hopefully you live close to work, and obviously, let's not go all the way to 98. Let's go just to 10. You guys are only creating a little over 5,000 pounds of CO2 a year. That's just enough to fill up nearly 10 regular big size balloons. So that's pretty good. I want each of you to know that if you sent me the information in advance with your numbers, I will be spending some time in between our morning program and our afternoon program today going through and getting you the calculations. And so to the internet schools and the view-only schools and the other good folks who have sent us your information in advance, I'll be able to send you that via email. Anything finally on carbon footprint you would want to talk about, Bill, as we begin to shift from here and move through the exhibition so the students can see a little bit more of it as we talk about another significant part of climate change, and that's sea level rise. Anything else about carbon footprint they'd like to?
Well, we could mention that the hybrid vehicles are often touted as more friendly, more green, lower carbon footprint, and in general that is true, but in the extreme case, if you're looking at electric vehicles that don't use any fossil fuels for their power, you still have to think about recharging the vehicle, and the electricity to recharge the vehicle perhaps was produced by a power plant where fossil fuel is burned. So even an electric vehicle has a carbon footprint if the electricity used to recharge it comes from a power plant burning fossil fuel.
Oh, now that's
an interesting misperception or assumption that people make is that it must be a zero carbon footprint vehicle.
Oh, that's a really good point. Carol, you want to add something?
I might add something about the importance of those trees. We always look at how are we going to capture the CO2 and the carbon, and a lot of research is going on ways to pump it underground, to do many different ways to capture that CO2. You have trees who do it for us on a natural basis all the time. So they're a very important part of the solution.
So planting trees makes a difference.
Planting trees and protecting the trees we have, it makes a huge difference.
So as we mentioned, we're not going to be able to talk about everything related to climate change today. That'd be way more than an hour. But a second major focus we wanted to look at was how climate change might affect sea level rise. Because obviously, Bill, as the Earth's temperature rises, we're going to get ice melting. That's correct?
That's correct, right. But there's actually two reasons why sea level will rise with a warming Earth. One is that water expands as it gets to higher temperatures. So even if you're not melting ice, a fixed body of water will start to occupy more space as you warm it up. It's a relatively small and gradual effect in the climate change scenario. But the other more dramatic effect would, of course, be the fact that you're melting a fair amount of ice that might be located on land now, and therefore the water ends up in the sea potentially, and that will raise sea level as well. Another sort of misperception is that melting icebergs will raise sea level. Not true. It actually doesn't.
Interesting.
The water's already there.
That's true, I guess. It is the same amount of water. It's just in a different form.
Right. Okay. So it's the land ice that may get melted, like land-based glaciers and permafrost and other sources of water that then eventually drain into the sea that actually contribute to sea level rise.
Oh, that's a good thing to know. We asked you guys to think about sea level rise in relationship to both people and animals. The animal we were going to look at is polar bears, and the people we were going to look at are the ones who live on the island of Manhattan, because obviously if you live in a location that's near a coastline, sea level rise is really going to matter to you. Let's bring up a map of Manhattan so you guys can see the entire island of Manhattan here now. The island of Manhattan actually has 1.63 million inhabitants on it, so a lot of people live on this island. It's a pretty dense spot. And if we wanted you guys to look at some different locations on the island of Manhattan. We'll look at a numbered map now, which gives you the numbers of the locations we were interested in you guys identifying for the program. And I want to go to our student groups to see what they might be ready to identify. Putnam Valley, would you take the opportunity now as you look at this image which shows the numbered maps, the numbered locations, if you guys would tell me locations 1 and locations 2, what do you think location 1 is and what do you think location 2 is, Putnam Valley?
Location 1 is the Empire State Building, and location 2 is the Trump Organization.
Yeah, that's all part of the Rockefeller Center there, the huge, big NBC complex, Trump complex, all sorts of things that are going on there with number 2. Let's go to Mount Tabor Elementary School in New Albany, Indiana. Mount Tabor, could you guys share with me locations 3 and locations 4?
Abigail, go ahead.
Location 3 is the World Trade Center, and location 4 is Central Park.
That's right. Location 3 represents the location of what was the World Trade Center and is being rebuilt now. And location 4 is the Metropolitan Museum in that area of Central Park. That would be the southeast quadrant of Central Park. Now, those locations are important because we wanted to give you an idea of the breadth of things that exist on the island of Manhattan. You're dealing with things that have major economic impact, obviously, like the World Trade Center. You have things that have obviously major cultural and artistic impact, like the Metropolitan Museum. You have things that are major business impacts, like the Empire State Building or the Rockefeller Center. all of those things, not just individual people's lives, are going to be affected because an island or a location with a coastline might be affected. Our recent experience in Japan will probably tell us that living near a coast really matters. We also asked you guys to find out some information about some other locations. And one of those locations that I asked you guys to talk about was Wall Street. And we learned from Sacred Heart, who's joining us via the internet, that Wall Street really matters because it's the financial heart of the United States. It's an extremely important financial location. I also want to ask you guys at the other locations, let's go to Stonewall Elementary. Do you guys have an idea of why Pennsylvania Station might matter? Why would we care about Pennsylvania Station being on the island of Manhattan?
Maybe it's because it's next to it, unlike Pennsylvania.
Oh.
And it has second oldest state.
Okay, it's not. It is named for Pennsylvania, but it's not. Its location is not related to that. Pennsylvania Station is actually the major railroad hub that comes into the island of Manhattan. Over 600,000 passengers. That's really a location that's going to matter to you. A third location we were interested in, and you guys can see this as we look at our map of Manhattan, which has all of these locations on it, was Times Square. And I wanted you guys to think about why Times Square might matter. Summit Arts Academy, why is Times Square important?
Because it's the middle of Manhattan.
It is in the middle of Manhattan. Do you guys know what happens at Times Square? What major things occur in Times Square? What would be examples of things that you might see or do in Times Square?
New Year's Eve.
Yeah, for sure. It is a major entertainment hub. So that's like where Broadway Theater is, which is an extremely important part of New York's economy, obviously. Huge amounts of stores. I mean, if you've ever seen images of Times Square, you see all those big lighted neon billboards, so to speak, all of the major stores that are there. When we think about the economic impact of sea level rise, what's some basic information you'd want the students to consider, Bill, before we look at what's going to happen to Manhattan here?
Well, I think one of the aspects of the economic consequences of sea rise is the question of how rapidly might it occur. If it occurs over, a centimeter a year for the next 200 years, that's one economic consequence, and maybe you could make an argument that you could deal and adapt to that as it goes on. On the other hand, if there's a relatively rapid sea level rise, such as might occur if, for example, all of the ice in Greenland slipped off Greenland and into the ocean, there would be a pretty catastrophic increase in sea level. By that I mean a couple of meters. And that might happen over a year or so. Okay. That's a different matter altogether because a lot of infrastructure would be unprotected because of the unexpected event. Well, so the timing is crucial.
Well, let's figure out what's going to happen to Manhattan potentially. We've got a model of Manhattan here, and Carol, this model is important. You wanted people to actually be able to get a visual sense of how Manhattan might be affected by rising sea level, correct?
Well, we looked at Manhattan as sort of that model big city. And so if you could see how a rise in sea level of a meter, a couple of meters, 3 feet, 6 feet would do to a big city like this, it helps people visualize how this might happen in other major cities near a coast around the world. But visualizing it is so much easier if you have a model to help you do it.
And you guys are going to notice as we look at the map of Manhattan, you're going to see sea move in and out, and we'll talk about the differences in a bit. This map of Manhattan, this model represents a part of Manhattan Island. And I want you guys, based on the models, the maps we sent you, to hypothesize where you think this might represent. So we're going to show you 5 different options now. Our first option takes you as far north as what is the first location we talked about on your map, the Empire State Building. Do you think sea level rise on this map might be represented by that? Option 2 takes you further up to the Rockefeller Center area. Option 3 takes you back south to the World Trade Center location. Option 4 takes you all the way north up to Central Park and the Metropolitan Museum. And then option 5 kind of cuts the difference, so to speak, between the World Trade Center and the Empire State Building. This map represents part of that. And I realize when you guys look at this map as we show this model now, it might be very hard to make an educated guess between what you see here and what you see on your maps. But I'm going to let you guys give it a shot. Putnam Valley, which one of those options? Do you think this map represents the sea level rise all the way up to Central Park, or just to the Empire State Building, or the World Trade Center, or what? Putnam Valley, what do you think this might represent?
Empire State Building.
The Empire State Building comes.
Empire State Building.
Very cool, Putnam Valley. They think maybe the Empire State Building. Let's go to Mount Tabor Elementary. Mount Tabor, what do you guys think? What's your guess?
Aiden, go ahead, sir.
The Empire State Building.
Aiden thinks it's the Empire State Building. Thank you, Aiden. Stonewall Elementary in Fayette. What's your guess?
The Empire State Building.
All right, we love the Empire State Building today. And last but certainly not least, Summit Arts Academy. Fayette, I'll let you guys mute again. And let's go to Summit Arts Academy. What's your guess?
Only Corey speak.
What was that again, Summit Arts Academy?
The Empire State Building.
Okay, great. We have gifts from Empire State Building for everybody. I'll have all of you mute your microphone because as we look at it, and we'll bring up a map that we've got of what this represents. Carol, this is the area below Chambers Street on the island of Manhattan, correct?
That's correct.
So this is fairly south. It's a little bit north of the World Trade Center, as you'll see on the map that we give you there. And interestingly enough, 55,000 people live in this part of New Manhattan, even though this is major business economic area. And so there are residences here as well, of course, as the Wall Street Financial District that's in this area, the World Trade Center, the Staten Island Ferry Terminal. Remember, guys, sea level is not just going to affect what's above ground, but think about New York and the subway system and what's going to make a difference in that regard. And if water level rises, can the Staten Island Ferry operate in the same way to get people out to that borough of New York where they live? You guys probably have questions about sea level rise for Carol and Bill, so let's find out what they are. Let's go to Putnam Valley first, Putnam Valley, New York. A question from you guys.
If it floods, will the people have to evacuate, or will they be able to stop it?
And would people be able to get away if it flooded? And Bill, that's all about the time frame, correct?
Yes, that's right. If it occurs over a relatively quick period of time, like a matter of hours or days, then that's one matter. If it's over much longer periods of time, even up to a few months, and it can be anticipated, then you can have time to do an orderly and safe evacuation.
And for the most part, Carol, we are talking about a situation which is probably going to occur over time as the climate changes, as temperatures rise, correct?
It is going to happen over a period of time, and part of the reason you create models like this, engineers use models like this, structural engineers, to say what would we need to be thinking about in terms of these building structures, in terms of the kinds of models we would need to put in place to begin to anticipate. And so just as visitors can use a model here, so can engineers and structural engineers to plan the future.
That's a very good point. And obviously this is very different than what you may be familiar with as a result of the recent tsunami in Japan, which was a sudden catastrophic event very much along the coastline and went about 2 to 6 miles inland. But that was a very different kind of event than we would experience here with temperature change. Let's go back to Mount Tabor Elementary again. A question from Indiana.
Okay, Ian, go ahead, sir.
Are any of the buildings structurally sound where the water wouldn't knock them over if the water level rose?
Well, water level in this building structure is certainly going to make a difference when you think about structurally sound buildings. And Bill, obviously we try to retrofit and make buildings ready for earthquake damage and that kind of thing. But when we talk about construction changes that would need to occur, are we talking about raising like seawalls, that kind of thing? Is there anything you could actually do to a building to make it more water resistant, so to speak?
Not so much for the building itself. May not be economically feasible to do it on a building by building basis, but you might be able to protect a region with, just as you mentioned, a dike or some sort of artificial structure, a dam that could hold the water back, so to speak.
But as if I create a dam or a dike along this area of the bridge, of the island, that water's still going to have to go somewhere, right?
Yes. Well, you have to build it around the entire peninsula or around the entire island, because otherwise the water is going to come in wherever it can possibly come in and fill up the space.
Good for you guys to think about. We're going to switch from the island of Manhattan as we continue to talk about sea level rise and begin to talk about animals and the effects of certain animals on sea level as well. And one of those is polar bears. And as we begin to move to the polar bear part of the exhibition, I want to see if Stonewall Elementary, do you guys have a question from Fayette, Kentucky about sea level rise? Go right ahead.
Sea level rise, go right ahead.
What would happen? What would happen if a severe flood happened?
What would happen if what? I missed the end of your sentence.
What would happen if a severe flood and it rose like 6 meters? The water rose like 6 meters.
I'll ask my producer to repeat that again for me. Oh, you're talking about the amount of time the flood might last. Obviously, that's going to make a very, very big difference. I mean, we're talking potentially the need for populations to actually move from where they are, right, Bill?
Yes, that's right, because the sea level is not going to recede anytime soon unless we have a cooling event or some other mechanism to get the sea level back down. So it's more or less a permanent change in terms of human lifetime. And so the changes that you make have to be permanent if you're going to deal with it appropriately.
And obviously the change of lifestyle is not just affecting people, that would matter to us greatly, but obviously it affects animals as well. And we've got an example of one here, polar bears. And we've got some other pictures of polar bears we can show you just so you can see them up close and personal, so to speak. Polar bears, obviously, as we look at these pictures, they live in the Arctic Circle. There are about 20 to 25,000 polar bears in the world by most recent estimates, and they actually exist in all sorts of different populations. So as you look not just as the map of the Arctic Circle and you see the ice at the top of the Earth, you also have a map here that shows you the different populations of polar bears, where you can see how they're herded out, so to speak. And polar bears are an important animal. I mean, they really, the sea matters to them a great deal, right, Carol?
The sea matters to them a great deal, but so does the ice. It's all part of their habitat and how they manage their life cycles, their hunting for food. So both of those things are really important to the polar bear. They're also a wonderful icon. Everybody loves polar bears.
And Mount Tabor, I think you guys had some information you had looked up about polar bears you wanted to share. What's some fascinating facts you found about polar bears you'd like us to know about?
Since the polar bears ice is melting, the polar bears population is dropping.
He's saying that the population of polar bears are dropping.
That's absolutely good information. The population of polar bears has dropped. We also learned some information from our good folks at Sacred Heart. Thank you, Sadea, for joining us. That it may be interesting to know that the polar bear skin is clear and not white, and that when polar bears are born, they're actually about as small as a mouse or a rat. And that's kind of amazing when you think about it, that a male polar bear can grow as tall as 10 feet and weigh between 550 and 1,700 pounds. So I kind of find it phenomenal that it could start out the size of a rat or a mouse. Bill, as we think, and we're going to go to Arts Academy in a moment for a question you guys have about sea level rise, but as we think about polar bears and ice flows, we have an image which shows some polar bears just on different ice flows. Talk a little bit about that and what we're noticing in the Arctic now in regard to sea level rise and how the ice flows are affecting polar bear life.
Well, what we're finding in the Arctic, of course, is that the sea ice itself is losing mass over time. And there seems to be a fairly steady trend over the years now of a little bit less and less sea ice each summer in the Arctic. And in fact, there's some thought that eventually we'll be able to resume trans-Arctic shipping routes that previously were not accessible to us anymore because of the melt of the sea ice.
Arts Academy at Summit, do you guys have a question about sea level rise? Go right ahead and ask it.
If the sea level rose, would Florida be the first one that got flooded?
Oh, if the sea level rose, would Florida be the first one to get flooded? Well, that's going to vary based on the geography of that specific location, but areas of Florida, Bill, would obviously be affected.
Yes, that's right. And we focused on urban built-up areas as our first example, but it's important to realize that there are many countries that have most of their land basically a meter or two above sea level. For example, the country Bangladesh, with a 1 meter sea level rise, most of that country is covered with water. That's quite a difference compared with New York. Of course, would be an issue, but it's not penetrating very far inland, as we saw from the example.
And Bangladesh, of course, located on the Indian subcontinent in Asia, right up there, if I remember my geography right, northeast of India?
Sounds right.
Okay, and if somebody can feel free to correct me if I missed that. An area that's really affected by cyclones a lot. You get a lot of flooding in Bangladesh because they're just above it. And Carol, there could be island nations that just end up being overtaken by the water, right?
Well, there are island nations now that are extremely worried because the salt water is beginning to come inland and affect the way they raise their crops, have effects on the water supply that they use for drinking. So this sea level rise makes a huge difference for the whole globe. And we are now one world, and we have to think about how we affect everyone. You
mentioned an important thing, the salinity or the salt level of the water. And that's an important thing for students to remember, that when obviously we're using potable, non-salty water to drink, and we're using that kind of water to rain on our crops, so to speak, irrigate our crop fields and feed our animals and all that good stuff. And obviously if salt water got into that system, into the aquifers, etc., it would really affect America's drinking water. That's right. So sea level rise is the second major area that we wanted you guys to think about in regard to carbon footprint rising climate temperatures and the result of climate change, but we also want to be able to spend some time on possible areas of solution. So we're going to continue to walk through the exhibition here and give you another video tour of more parts of the exhibition as we begin to think about an alternative source of energy. And the alternative source of energy we're going to talk about today, based on the emails I got from people, is geothermal. So put your brains to geothermal energy as Bill and Carol and I begin to walk through the rest of the exhibition. And Carol, as we look about the exhibition here, we walk through this section which deals with oceans and their temperature, coral reefs, and then eventually with land masses and how they would be affected by climate change. What are you really interested in people trying to understand as they go through this section of the exhibition?
Well, one of the things that's particularly interesting and important about the coral reef is that as carbon and dioxide goes into the water, the ocean is a wonderful absorber of carbon dioxide. We begin to change the chemical composition of the ocean, and corals that are very fragile have a very hard time with that, and in some cases they bleach, in other cases it totally destroys them.
Okay. We're now moving into the alternative sources of energy section of the exhibition, and you notice that they mentioned a number of them. There's solar panels here, there's wind turbines here, there's information related to nuclear power, there's information related to hydroelectric or water power, but one of the ones we want to focus on this morning is geothermal, and Bill and Carol, I'll invite you guys to join me here. Bill, I'll put you on this side, Carol over here. What you're seeing right here is a wind turbine, and that's obviously an important potential alternative source of energy. If we take Rob's camera, you may not know Rob, but I know Rob, and he switches to his right, you'll be able to see an example of a solar array as well. So there's a whole variety of different alternative sources of energy that matter to us. A real important reason why we're focusing on geothermal power today is because Putnam Valley Middle School informed me via email that they've got a geothermal unit themselves, some sort of geothermal power that they use for their middle school and their high school. Putnam Valley, would you like to come in and identify yourself, who's going to speak, and give us some information about what geothermally you guys have there to help heat and run your systems at your high school and middle school?
Well, we had geothermal heating and cooling in our middle school and at high school. It's a lot more efficient than using other types of ways to get heating and cooling, and there's a bunch of good things about it. There's no boilers, which can cost a lot of money. There's no boiler maintenance either, so it's really helpful.
Go ahead, Putnam Valley, continue.
There's no fuel or tanks in the ground, so there's no environmental protection agency trouble. So really, it's a pretty good thing.
Very cool. So they actually have geothermal to be able to heat and cool their middle school and their high school. And they're sharing with us the fact that obviously that means it reduces boiler maintenance and maintenance temperatures because they don't have to worry about that, and they don't have to worry about fuel at all. There's no oil, gas tank, or anything of that nature that they have to deal with. So Putnam Valley, we thought that was really, really interesting, and so we want to talk this morning about geothermal, see what questions students might have about geothermal energy to start with, and then as our time allows us, we can talk maybe about some other examples of alternative forms of energy as well. We've got some diagrams we want you to look at when you think about geothermal. Our first illustration of a geothermal is a diagram of a geothermal plant, and you're going to notice what it looks like, and then we're going to switch to an actual operating plant, which is in Iceland. The image you're going to see is from a plant in Iceland. And Bill, as the students think about geothermal energy, if we're going to do it on a large scale, not like a heat pump necessarily I'm going to use at my house, we'll talk about that in a minute. How does geothermal work? Am I literally pumping up hot steam from the earth, or how does it work?
Well, geothermal power as an alternative energy source comes in two basic sort of flavors, let's say. One is deep geothermal power, which really takes advantage of the fact that if you go deep enough down below the surface of the earth, temperatures start to rise very quickly. As we know, the earth has a molten core, and the temperature is very hot there and is quite warm, even relatively shallow below our feet. And at some places on the earth, that heat is rather easily accessible. For example, when you see a geyser, or when you see hot springs, or you see a boiling tar pit, that's an indication that that geothermal deep heat storage is actually at a place where it's close to the surface, and you can take advantage of that.
So like when I think about Yellowstone and Old Faithful?
Right. Those are places where you can contemplate using that heat to spin a turbine to create electricity. But the other flavor of geothermal is shallow geothermal, and that takes advantage of the fact that the temperature, typically 3 or 4 or 5 feet below the surface, is pretty constant year-round and varies only a little bit with latitude. It's basically in the 50s Fahrenheit. So in the summertime, if you can pull some of that 50-degree temperature up to the surface and use it in your house, for example, or in your school, you can potentially have nearly a free source of energy. All you have to do is pump it a little bit. So if you put a fluid down there like water and let heat exchange occur with that at 5 or 6 feet below the surface, and then bring that back up, that water is cooler in the summer than the outside air temperature. And you can do the same thing in the wintertime, because even if the temperatures are in the 50, that's still much warmer than the air outside. So you can use that with a heat exchanger to actually supply some of the heat for your wintertime use.
Oh, very
All
cool.
from the same source of energy, just 5 or 6 feet below your
Very
feet.
cool. We've got some illustrations that cover what Bill just talked about. The geothermal inside shows you the geothermal inside shows you the inside of the operation. He talked about the turbines, and so I'm going to bring that stuff up, and the turbine is going to be powered then, and that's what's going to be connecting to the electrical grid.
Right.
Because everything's got to create electricity for me, right? No matter what, folks, you've got to remember that we're all about creating electricity, because that's what really makes everything work in our house and in our businesses and everything like that. It's whatever source of energy we're using to get that electricity made. We wanted to show you a map of geothermal possibilities in the United States. The areas that are darker in orange, the more burnt orange, are the ones where the temperature is hotter, and you'll notice Yellowstone and that area would obviously be affected by that. And then last but not least, we wanted to show you an example of an illustration of what Bill was talking about at the end, which was the kind of like geothermal heat pump which you could use near your house, which is much shallower, and could actually do that cooling for your house, or provide you heat for your house, and it's probably similar in some ways to what you guys might have at Putnam Valley that's working for your middle school and your high school heating and cooling system. Carol, in general, why do you think it's important that when people come through this exhibition, they really begin to think about alternative sources of energy?
Well, I think, you know, you come through this exhibition recognizing that as our nation and nations around the world, we need to do something, and we need to begin to make good decisions to help sustain our Earth. But you also have to know how you can go about doing that. And so it's going to take all of the wonderful ideas people have, whether it's geothermal or solar or wind energy, to come together to help us resolve this in a way that manages the CO2 emissions on Earth. So we wanted people to leave with what are the options, so they could begin to understand what the future probably is going to be of energy production.
You raise a very important point there. It's a combination of these sources, and one of the ideas we definitely want to get across to students is that obviously not any one of these sources is going to make the difference for our use of carbon or fossil fuels now. It's not like we can get rid of fossil-based fuels, burning coal and burning oil, and suddenly go to geothermal or go to wind power or go to solar power. It's a combination of those things. And you've also got to think about the time frame, about the transition, because you've got to remember that there's economic effects, obviously. There's all sorts of industries tied into fossil fuels and our carbon footprint. So as we switch over, we've got to think about that as well. So your questions on geothermal energy or on the other alternative sources might deal with that or the sources themselves. Let's find out what you guys want to ask about geothermal energy to start with, and then other energy sources. Putnam Valley, a question from you guys?
What do you think is the best alternative energy?
Oh, Bill, do you have a preference yourself for what might be the best alternative energy? And the best might matter in a lot of different ways, so let's look at it in a variety of different ways. Is one more cost efficient, possibly? Is one like more easily used in America on a larger scale? Would one be simpler for me as an individual to think about?
Well, I think some of these points have been brought out already. It really matters where you are. Certain kinds of alternative energy are much more feasible in certain locations. Some places are windy and some places are not. Some places are sunny, some places are not. Some places the deep geothermal energy is accessible, some places it's not. So just as you said, it's really a combination of sources of alternative energy that's customized to the particular location, and then the scale of the need. If you're interested in heating an individual residential house versus what about lower Manhattan, those might be different solutions depending upon the scale of energy needed.
Okay.
You know, and I might add something too, that getting energy from one place to another is not a free ride.
Right.
So if there's a place where there's a great deal of wind energy that could be used, but you're in a city that is hundreds and hundreds of miles from that energy source, it's not at the moment practical to move that energy source from one place to another. So that comes into our thinking as well.
Very cool. Let's go to Mount Tabor Elementary in New Albany, Indiana. Mount Tabor, a question from you guys?
On the geothermal stuff, we saw that like steam coming up out of it. What, like, does that, how much pollution does that cause?
So is there a pollution worry from the steam coming out of the earth with geothermal? That's a good question, Matt
Yeah,
Tabor.
it's a very good question. Much of what you see there is steam, literally, so it is water vapor made visible. And that, in principle, is fairly clean, but there are other gases that are mixed in. So in the geothermal, the deep geothermal energy technology, you're spinning a turbine and then you need to eject that steam. In principle, that's clean. It's just like a cloud of water vapor, water droplets. However, with the geothermal energy, deep energy source, there are other pollutants that are released at the same time, a bit of methane, there may be some heavy metals like mercury in the vapors and so on. So these are not entirely clean, whereas in fact the shallow geothermal heat source is pretty much pollution-free itself. As I mentioned, you still got to run the pump, and that depends on where. A great solution would be, if you can do it, is to use a solar panel to supply the electricity to the pump that then drives. Then you've got a zero carbon footprint. The only thing you have to worry about is, well, what about the energy that was used to manufacture the pipes and the pump and stuff like that?
But at some point, I mean, it's all about reduction. It's never going to be about elimination.
Right, that's right.
And don't forget, if you're watching over the TV or the web, or you're a view-only school, whether you're Midview East in Grafton, Ohio, or your Wappingers Falls, New York, or your Forest Heights Academy in Baton Rouge, or Sacred Heart in Sedalia, or anybody else who may be watching I don't know about, send us your email questions to live@hectv.org, because they are indeed now getting them via email and sending them to me via text message. So I'm using amazing about what you can do with technology today. Let's go to see what students have questions more on about geothermal alternative energy. Stonewall Elementary in Fayette, Kentucky. Fayette, a question from you guys for Bill or Carol?
How much geothermal energy can you have in your house?
How much geothermal energy can you have in your house? Well, part of that's going to depend obviously on your location and the size that you want your geothermal heat pump to be, but it's possible, Bill, to do a pretty darn good job, right, in your house?
It is. There's a practical matter of, I mean, there's two ways to build these shallow geothermal systems. Either you can bury pipe rather shallow but over a large area. So if you have a lot of land associated with your house, then you might be able to do it that way. If you don't have that option, you have a relatively small yard, so to speak, then you need to drill down quite a bit. You got to get a certain length of pipe to do the heat transfer, the heat exchange that's needed. So the solution that involves drilling deep is more expensive than the one that involves laying pipe rather shallow but over a large area. The idea is you got to have a certain length of pipe one way or the other.
Okay, and let's go to Arts Academy at Summit in Canton, Ohio. A question from you.
How many geothermal power plants are in America?
Oh, the number of geothermal power plants in America, that's a great question, and I'm afraid I don't have that information. Bill or Carol?
I don't believe I would know that answer either, but there are ways to look it up. I would encourage the students to get on the internet, do some research.
And if you find out that information, feel free to email it to me and let me know, because I know we're about 8 minutes from the end of the program, so you might not find it by the end of the program, and I'll be happy then to email it to all the school groups that joined us today so we can share that information. That's a really good question to think about. We also want you guys, as we look at solutions, to think about what you might be able to do, and we're going to move over here to this part of the exhibition, because Carol, this represents ideas from all sorts of young people who've actually walked through the exhibition, right, about what they might be thinking about how they could do something to make a difference.
Well, we realized that as people go through this exhibition, they start to have ways they think they can make a difference, or things they've learned that they want to share with others. And so we provided an opportunity for people to put their ideas up here, and it's been terrific. All of our staff has come and read them, and we're looking at ways we can incorporate that into things we share with our visitors.
Oh, very cool.
But
Bill, I'll have you move to this side
for
a minute so I can go through some of the examples.
Okay.
Because we want you to think about that as well. So I'm going to share some of the examples we've got up here, and then I'm going to go to each of our interactive groups to see if you guys have something that crosses your mind you'd like to share, and we can actually write it and put it up here, and then the world will know that you joined us via video conference at the St. Louis Science Center, and do that. And as I begin to do that, we got an email question that goes back to ice cap melting. It's from Caitlin Oak Grove Elementary School. Thanks very much, Caitlin. They said in preparation for the program, they studied the Baffin Island ice cap and its current melting. And do you have any sense of like what its melting rate is, or how long it might take to totally melt, or what we should be worried about with the Baffin Island?
I'm sure that's a very important question. I'm afraid I am not familiar with it myself. I might know something about it, but I don't recognize it by the island name.
Okay.
So I can't help you too much on that one.
So look up that information if you're at Caitlin Oak Grove, and if you find out information, send it to us, because it would be good to know.
Yeah, let me know about it too.
It would be very good to know. So we've got a variety of different solutions potentially here. Plant trees, use better and new light bulbs, turn off lights when possible. We need to consider that the Earth is where we live, where our future will take place. We need to quit complaining about the global crisis and act, according to age 14. Erica, I'm going to say is her pronunciation, and Erica. Daniel wants us to know that we should switch to renewable energy. Owen, I believe, is interested in switching to CFLs, fluorescent light bulbs. Thanks for that illustration. And according to K and G here, trees are the answer. So we've covered a nice gamut here. I want to go to each of our student groups for a final question, potentially for Bill and Carol. I don't know where Paul came from, but for Bill and Carol, and also to think in terms of what you guys might want to offer as a solution yourself. And I'm going to pull out a piece of paper and a writing utensil so I can jot them down. So let's start by going to Putnam Valley. Putnam Valley, a final question or a solution you'd like to offer to put up here?
Well, I know that not much land in the United States can support geothermal energy plants, but what percent of the United States can support it?
What areas of the United States could support geothermal energy? What percentage? Well, if you go back to that map we had, which shows you the U.S. map of the geothermal location, I'm not sure that I'm going to be able to tell you what the percentage of it is, but you're going to notice that almost the vast majority of it's going to be located. Pardon me?
The exhibit suggests it could be about 5%.
Oh, thanks, Carol. The exhibit suggests it can be about 5% of geothermal of the United States that could provide that. And you'll notice the areas of the United States that it could be affected by are the ones that are in the deeper orange, the more burnt orange colors on your map. And let's go then to Mount Tabor, Indiana. Mount Tabor, do you guys have a question and or a suggestion you want me to write down for the board?
If we rode our bikes and public transportation more, we would save a lot. We wouldn't have as much pollution.
Thank you very much. Riding our bikes more, using more public transportation. That's Mount Tabor Elementary, New Albany, Indiana. And as I write that down, let's go down to Stonewall Elementary in Fayette, Kentucky. Stonewall, a suggestion or a final question? Let me go instead then to Arts Academy at Summit, because I could not hear in my ear if you guys had a question or a comment. So Arts Academy in Canton, a final comment or question from you guys.
I have a suggestion. We could use more efficient sources of energy.
Excellent. We could use more efficient sources of energy. And is there a certain more efficient source of energy that you would personally like to see us use more of?
Solar power.
Okay. Use more efficient sources of energy. Solar power. I'll make a big sun here. And that comes from Arts Academy at Summit in Canton, Ohio. And Bill, as I write this down, and you try to think about summarizing some important ideas and Carol will ask you the same question. What are some really important concepts as we sit here in the alternative energy area that you'd like the students to understand? And I know I can only give you about 60 seconds for it. So.
All right. Well, one thing that we haven't talked very much about is the possibility of reducing carbon footprint of energy production by cleaning up fossil fuel usage. For example, it might be possible that we could still use coal to produce electricity in power plants if we could find out how to remove the carbon dioxide from the exhaust before it reaches the atmosphere. So this has got a fancy name called carbon sequestration, and a number of scientists and engineers are working on concepts to accomplish this that would allow us to still use the fossil fuel that's available to us, but use it in a cleaner way. So reduce the carbon footprint, but still get away, so to speak, with using natural gas, oil, and coal.
And Carol?
I think the important thing we wanted people to know in helping develop this exhibit is that every effort every person makes adds up to a great deal, and that the young people who are sitting in our classrooms and listening in today are the ones who will make the biggest difference for our future. And I'd really encourage you to think about science as a career and see how you could be part of the solution. We value that greatly.
Well, Carol, it's been an absolute pleasure to be here with you this morning, and Dr. Dannevik, Bill, thank you so much as well. We'll be back this afternoon for another program as well, and of course this program will be archived on our HEC TV website. You can simply go to hectv.org in about a week or two, and it'll be up and running for you so that you can see the archive version and use it in classrooms later, and it'll also be on our HEC TV page on iTunes U. I want to thank each of our interactive schools for joining us this morning, and those folks who joined us via view-only video conference and web stream as well. Remember, if you sent us some information in advance that we didn't get to in the carbon footprint section, I'll be doing that math for you between programs, so I can send you that via email. And if you have more questions for Carol or Bill, now that have crossed your mind as a result of this conversation today, then send them to me at live@hectv.org, and I can forward them to them, and they can answer them, and we can get those responses back to you. We're going to be very different for HEC TV Live in about a month. We'll be switching out of the world of science and we'll be going to the world of jazz music. On April 19th, we'll be at Jazz St. Louis for an Inside the Artist Studio program about jazz. And then we'll be back at the end of April to work with the St. Louis Science Center again with the first Robotics World Finals competition, which will all be about science and robots and engineering. Really, really cool stuff. Bill, thanks again for joining us. Carol, thanks for being here. Thanks to all of you for being here. Come to the St. Louis Science Center. It's open from 9:30 till
5:30.
5:30 every day, and on the weekends it's
the same hour.
9:30 to 5:30 every day, and it's free.
It's one of those
fantastic places in St. Louis that's here for free. So come see the exhibition. Thanks so much for being part of HEC TV Live. Bye, everybody.